Hello. This is going to be a quick test review over... I'm not sure what pre-cal unit this is, but it includes law of cosines, law of sines, it has the triangle applications, parabolas, eclipses, hyperbolas, general forms, so basically a lot of triangle application. So, I mean, shouldn't take too long. I don't know how many is that. What is that? 1, 2, 3, 4, 5, 6, 7, 8. About 8 questions. I don't know how long it'll take. Hopefully it'll go quick, but yeah. Let me just... Okay, so let's start with number... start with number 1. Where's my... Okay, so basically, just one step to solve the triangle, which means just to get this. Find B, find C, give the missing angles on the sides that we don't have. Should be easy. What we notice here is that we have an angle, we have a side, right? And what that looks like is A, S, and obviously that will be law of sines. We'll be using law of sines this one. So what we know about law of sines is that we have this side, this is A, and we have angle A. And then we have B and we have side B, and let's find side B first. So first of all, we have the law states that we have side A, 32, over sine of angle A, which is 30, is proportionate obviously to B, the side we want, and sine of B, which is 5 degrees. So I have the calculator right here. What you're eventually going to do is, can I highlight? Yeah, you're going to, oh, that's bad. Okay, so you're going to cross multiply. Eventually, you're going to isolate B as 32 sine 45 all over sine of 30. And now you just plug that into Desmos. I will plug it into Desmos and get B. That will give us that this side angle right here, B, is 45.255 feet, because yeah, this is that. So what I'm gonna do, nope, hold on, sorry. Am I doing it wrong? I'm definitely doing it wrong. Okay, I'll just keep that there. It's a little big, but it's whatever. Okay, so now we have side B. Check, got that out of the way. Now we have side B. We can do, we probably could have gone side C equal. We just do 180 minus 30 minus 45. That gives us that sine or angle C is just 105 degrees. And now all we're missing is side C. So we do that same law of sines proportion. Let's use A just in case we messed up B. And it's a bigger number anyway, so let's just use A. We know that angle C is to sine of C, as A is to sine of A. We already have this, so we're just going to isolate that. So let me just plug in the values. So we're looking for, side C, so C over sine of 105 is 32, which is side A, over sine of 30. So you do that, you'll eventually get C, well, after you cross multiply, you'll get C is 32 sine 105 all over sine of 30. Okay, so plug that into Desmos or whatever calculator you're using. That means that you will get C, side length, as 61.819 feet, if you round correctly. And look, we have, if you can't tell, that's a sine, that's a side, and that's a length. So we got C, we got B, and then we got angle of sine C, which we were pretty much given, almost. So we just solved that triangle. Now let's go ahead and move on to example 5. Okay, so this one actually wants us to draw a triangle because it doesn't necessarily give it to us. So let's see here. Solve ABC if A is that, C is that B. Okay, so let's just draw this. Boom. We got A, we got B, we got C. Okay, we know that A, we have side A, which is across from angle A, so right here, 6.2. C, same thing, cross 9.5. And angle B is 75 degrees. So if we use our brains, we know that we have a side, we have an angle, and we have another side. SAS, that obviously means we'll be using the law of cosine, right? And if you don't know the law of cosine, it is C squared is A squared plus B squared minus 2AB cos of angle C. So in case you don't know that, it's going to be there. Now let's see which side we can get first. So we're looking for B right now. So like B, okay? We're looking for that. So, and let's call this is A, this is C. So let's just plug it into that formula. B squared is obviously, if we move it around, it's going to be A squared plus C squared, right, and whatnot. C squared, and then it's going to be minus 2AC cos of B. So it's basically an alternate. Usually this is C, that was B, and that would be whatever term's here. But now since it's B, obviously that this is going to match that. Okay, so if we plug in the values, we're going to get that, we're going to get B squared equals 6.2 squared plus 9.5 squared minus 2, okay, times 6.2. This is not working. Hold on. Yep. Okay. Actually. So we're just gonna scratch that. Okay, and B squared is 6.2 squared plus 9.5 squared minus 2, 6.2, 9.5 times cos of 75. So that's a long equation. You're just plugging in the values, whatnot, cos of 75. Plug it into Desmos, you should get side B. Well, after you square root both sides, this should be your actual thing. You'll get that the value of B is 9.909. Okay. Let's see here. Nope. Okay. Nope, never mind. I'm just going to erase this part. This is really hard to use. Okay, so now we have B. Okay, we have B. And now we want to get angle A and angle C. So since we already have this side link, we can just go back to the law of sines, right? And that tells us that sine of A, which let's just plug it in. So that's what we're solving for, sine of A. That is an A. Over side length A, which is 6.2, is obviously proportionate to sine of B, which we know is 75. So sine of 75 over B, which is what we just found, right? 9.909. Okay, great. So that's B. Like we did again, we're just gonna boom, cross multiply. That should give you after you isolate what you're solving for, which is sine of A, that should give you sine of A is A sine B over B, and you plug in the values here, and then you arc sine both sides to cancel out that sine, do all that. That value of angle A should get you, well, after you round and everything, A should be 37.181 degrees. Okay, so now we have angle A, boom, and angle C. It would be stupid to do all that work again because we know that the angles add up to 180. So all we have to do is 180 minus 37.181 minus 9.909. So if you get all that, you'll figure out that C, missing angle, is 67.819. Hilarious. Okay, so that's that. So example number 7, which is, let's see here. So it's actually, unlike the other ones, this one's asking us to solve the triangle, asking us to find the area. And the thing with the oblique triangles, which is most likely what this is the formula for area is, well, area, yeah, 1/2 AB sine of C, angle C. That's your area formula. And getting on this, when you just plug in the values, A equals, let's label this. Okay, so this is a side, this side is an angle. And if you were to draw this, that is an embedded angle. So this value can be A, this value can be B, this value can be angle C. It's an angle. Okay, so you plug it in. 1/2 A is 23, B is 20, and then you do sine of angle C, which is 40. Okay, you get all that out. That should get, well, you plug it in, your area will be 147.841. And I guess we can just add square units because we're not sure in its area. So good labeling skills. Okay, that one was a really quick one. Okay, so we got law of sine down, law of cosine down, area of oblique triangles. Let's see this one right here. Okay, there's another one. Another find the area of a triangle, except they give us side, side, side. And the easier way, obviously, Heron's formula to get the angle of the triangle when you have all the sides is, we know that what he claims S is, so S is all the sides. He should be A, B, C, and whatnot. So it's going to be A plus B plus C all over 2. So that's your S value, right? And you do that, 5 plus 7 plus 10 over 2. That gives you 11. So S in this case is 11. Okay. And his formula basically says that, get that out of the way. His formula basically says that area is just S minus A, S minus B, and S minus C, square root of all of that. So we're just plugging those values. A is just square root of S, which we found as 11, and then 11 minus 5, which is A, ABC, so then we got 11 minus 7 for B, and then we got 11 minus 10 for C. So in other terms, if you plug that in a calculator, you should get that area is 16.248 square units. And that is your answer. So it's another formula to get the area of a triangle, oblique triangle. So let's get another one going on. Okay, so you can see, kind of draws a line here. So if we were going to label what we just did, so that would be law of sine, law of cos, and this is just area of oblique triangle, and this is this, but this one is Heron's formula. Okay, so you see that all of these are kind of triangle applications. So let's just label that. Nope. Triangle applications. Applications. And then we go here. These ones are going to be, obviously, the second part, safe to say, of the unit, which are conic sections. So I'll just write conics, something like that. Okay, so let's go back here. So it's asking us to write the standard formula of the conic given by the general form equation, then identify the conic. Okay, I think, honestly, that, we can do that first. Usually this is on the last, but it's going to be out of order anyway. So, yeah, I feel like we can do this anyways. So, this is how you do it. So what you want to do, you want to first get your terms. There's going to be a lot of work, so you want to get your terms together. So let's just get x squared right here plus 10x. Okay, now we're going to get our y's. So we got y squared, we got minus 18y, and we want to just move that over here. So negative 42. And we just want to complete this to the values. So we're going to have x squared plus 10 is really bad at drawing with this. Plus 10x plus that value. And then y squared minus 18y. And then some value equals negative 42. So obviously complete square, you want to divide this term by 2 and square it. So it's just going to be 25. Yeah, 5 squared, 25. Divide this by 2, this negative 9 squared, which is just 81. Okay. So obviously you can't, by the way, in case you missed, you can't factor anything out of these two terms. So that's why there's nothing out here. If it is, you'd have to multiply it by, and then do it over to the other side. So what we just did, we made out those terms. We have to compensate them here, and the 25, and then you want to add the 81. Okay, now obviously you want to just factor these back again. That's just going to be x plus 5 squared. This one's going to be plus, obviously, y minus 9 squared. And then do the math over here. That will just simplify down to 64. Now, the thing with this, there are, I think, 3 options for what it can be, what type of conic it can be. But, if you were to divide this by 64, right, divide this by 64, you could theoretically say that it could be a, in this specific occasion, you could say that it is, what's it called, an eclipses? But the thing with eclipses is that divide all this by 64, you could say, well, look, it's an eclipses because it's a sum of things, but the difference is in eclipses, one of these has to be bigger than the other, right? This would be theoretically A or something, this would be B. A has to be greater than B. And if they're the same value, then that just ruins the definition of an eclipses, so can't be it. And it can't be a hyperbola because it's the sum of these two. Okay, so that's pretty much it. So that's how you know it's a circle. Also, 64 is a perfect square. So we got the equation down, and it's obviously a circle. So the radius would be obviously 8 for this. So that's the general form. That's the standard form, and that's the conic. So now we're going to graph hyperbolas. I feel like this can get annoying, graphing hyperbolas. I feel like a hyperbola in general is just annoying, but we can do it really quickly, actually, because I don't know how long this is dragging, but okay, so a hyperbola, it's important to know kind of aspects of it. But what we do know is that usually the top is going to change. Well, not usually, always. Only the top is going to change. So the way to see if it's a vertical or horizontal hyperbola, see which term is first. Looks like it's x. That means that it's going to be horizontal, so it's going to look something like that. Okay, great. And we know that the bottom terms, the one on the bottoms don't change, so obviously going to be let me make that better. So that's going to be a squared, 25 is a squared, and 16 is b squared, or a is, let me do this easier to write. So a is going to be 5, b is going to be 4. Okay, now when you know that, usually we'd have a term here that's like x plus something squared, y plus something squared, minus something, whatever. But we don't, so it's really easy. Our origin, our center is at the origin. Right there. That means our center is just going to be 0, 0. Nice and easy. Great. Our vertices, since it's horizontal, we're going to, however the distance, it's going to be 2a, or just a on this side, a on that side. Because it's horizontal, that will give you to our vertices. So obviously a is 5, so our first vertex is going to be here, and then move 5 over. That's our first vertices, and then move 5 the other way. Okay, there we go. So if we were going to write these down, it's going to be -5, 0, and 5, 0. Okay. Foci. Okay. You know what? Since we're not even gonna since we don't have to plot the foci, I guess we'll just solve for it right now. Obviously, we know that foci is the distance from the center to the foci. That's what it's. Well, actually, no. It's actually for the points. Never mind. The distance from the center to the foci. That's our c value. To get c, we know that c squared. For hyperbolas, it's just a squared plus b squared. We have both those terms. A squared, we remember, is 25 plus 16 c squared. So c squared is 41. Wrote that. C is 41. 41. Yep. 41. So c squared root 41. Let me just write that here, I guess. So now we just basically add square root 41 from our center going towards our vertex. So it would probably be somewhere around here and here. So to plot it would be negative square root 41, 0, and root 41, 0. Okay? But we don't have to plot our foci. It's not going to help us. We know that the distance from our co-vertices, which is important, is that's going to be 2b, or just b up, b down. That means that up, we're going to have to go what b is, figure out b is 4. So we're going to go up, that's our co-vertices, and then down 4. Boom. Now we can just do this box. I guess that's going to help us draw it, get this box going. Okay, and so our let me include this length of transverse axis. That's just your long one, or well, that's not necessarily a long one, just the way it's opening toward your vertex. So it's always going to be 2a, and your conjugate is always going to be 2b. So 5 times 2 is 10. 4 times 2, that's 8. Great. Your asymptote, if you didn't know before, the equation is, for this one, since it's horizontal, it's, nope. Okay. Since it's horizontal, it's going to be y minus k equals plus or minus b over a h, or x minus h. Good thing about it, we don't have an h value, we don't have a y value, or a k value, so it's just going to be y is plus or minus, b is 4, a is 5, and x. Great. Nice and easy asymptotes. We, of course, start with our asymptotes from this origin because it doesn't have a starting point. So we go up 4, right 5. Do it again, up 4, right 5. Yep. Yeah, and so, yeah, and then we do the same thing down here. We already drew left 5, down 4, left 5, and then down 4, right here. Do that the other way, or we can just match it right here. Right here. Now we just draw it, or, here, 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 right? So I think that's everything we need to draw it, and we filled in everything in, so our vertexes, or our actual hyperbola is going to go something like that. It's going to open out horizontally like that. So, okay, we did that. Now, there's just a couple more. Let's go through these one quick. So, write the equation for eclipse with a major axis. This, and a minor axis with that. So, eclipses are similar, I guess, to hyperbolas. Essentially, so let's just, it's better to kind of visualize this. Yeah, it's better to visualize this. So how get more space? Okay. Actually. Okay, so well, this is actually probably better, honestly. I mean, it shouldn't be that difficult. How about this? Let's ignore this one. This one's actually not supposed to be here. I just realized this one is incorrect. It's not supposed to be here. Okay, so let's just do one. Let's say that we have foci at 6, 5, and the other one is at 6, -3. And we have a major axis, I'm just going to call it MA, major axis with a length of 10. Okay. So we know the distance between this foci and this foci is just going to be 2c. So, and we noticed that when we plot this down, number here is going to be 6. Let's say this is 6. It's going to be 6, -3 here, and it's going to be 6, 5. Okay, so this distance right here is going to be 2c, or 5 plus 3, 8. So 2c equals 8, c equals 8. Great. We have our major axis right here, which is 10. We know that that's just 2a. 2a equals 10, a equals 5. So we have a, we have c. Since it is a eclipse, we know that that's c squared equals a squared minus b squared. We have c squared, which is just 64. Nope, sorry, c, I did that wrong. C would be 4. So we have 16 equals 25 minus b squared. So obviously, just look at your head. B squared will have to be 9. And that means that b is just 3. Okay, so we have this. It's asking to write the equation. So let's get this out of the way. We know our center that we just solved for is the midpoint between these 2 points. And if you do math, add 4 to this, it's just going to be 6, 1. That's our center. Now we can easily just graph this. We don't need C, but we needed B. So it's going to be x minus her. So it's going to be x minus 6. Okay, square that. Since it's a so the major axis was a long one, and it was a vertical. That means that it's going to be a vertical. It's going to be a vertical one. That means that the a value is going to be with the y instead of the x. So we know our a value is 5. Square that. But the b value is going to be with the x. So b squared, that's going to be 9. We do our plus y minus 1 squared. Okay, over a squared 25 equals 1. Okay, really messy, but that's pretty much what it is. Yeah, ignore that the first one wasn't supposed to be solved. Let's do these two quickly and let's go. This is a really easy circle one. Gives us our center. It's -2, -1. Center's right here. R squared equals 16. R equals 4. Radius 4. Let's just do 4 to both sides. 4, 4, 4, 4. Boom. That's a really wonky circle, but it works. Yep. It worked. Okay, it works. So let's just do the last one. Oh my god. Okay, hold on. Hold on. That was a bad one. I just did it completely wrong. Okay, so actually, the center's not there. The center's here. Right? Center's, I'm just going to redo the whole thing. Just don't mess up like I did. Radius is still 4. But it's the center is -2. It's going to be here. Boom. -2, -1. Great. Same thing, 4 to all sides here. I actually messed up a circle. It's actually embarrassing. Okay. Next one right here. So this is a really quick ellipsis. We know that that's 4p. -8 equals 4p. Or, well, just 8. We don't care about the negative. P is just going to be 2. Okay, but we do care about the negative now. Looks like we start with y. Means it's going to be either like this or like this. And we know that's negative, so it's going to be this one right here. Let's do our center. So it's going to be x. Well, x is -1, y is -1. So it's going to be right here. Our p-value is 2, and we know it opens like this. So that means that our directrix is going to be 2 this way. This is going to be the directrix right here. And we know that our focus is going to be 2 that way. This is our focus. Yeah, so it's just going to open like that. But the thing is, we're going to actually have to do it. So we know that 4p is -8. So this right here should be -8. The focal length. The focal length is like this. If we cut it in half, that's going to be 2p, 2p. So 2p is just 4. So let's do 4 this way and 4 that way. Make sure to go through there. Through there. Okay. So that's pretty much what we did. Now we just have to questions. Get that out of the way. So the vertex was obviously -1, -1. Okay, our focus is right here. It's -3, -1. And our directrix, this line right here. Notice that the x value stays the same. So like this is 1, this is 1, 2, 1, 3, 1, 4. X value stays the same. So it's just going to be x equals 1. Because that's what it's staying the same at. Okay, and I think that is everything. Oh, nope, axis symmetry. And you just see where it's symmetrical right here. Boom. That is y equals -1. Okay. So I think that's everything for this study guide. What do you call test review or whatnot? So this right here, that is general form. You can't read that. Okay, that's general form. Graphing hyperbola. This one right here, I think this is a ellipse one. Okay. Go down here. That is a circle. And that is a parabola. So I think if I check mark everything. Yeah, we have all the conics. We have circle, parabola, ellipse, hyperbola. We have the general form. We have law of sines, law of cosines, area of oblique triangles, and Heron's formula. So things to remember for the test is just remember the formulas. I don't want to write them out. And just don't, I guess, something. Just remember the formulas. Yeah, that's pretty much it. So thank you.